Assalamualaikum and greetings to all of you. Today I would like to give a lecture on conservative 5.3, still on chapter 5 part 1 B, conservative fields, or we may call as independent of path. Okay. A vector field F is said to be conservative if there can be found some scalar field F such that F is the gradient of V. Okay. In other words, if F is a gradient of some scalar field, then it is a conservative field. Okay. So theorem. Test for conservative vector fields. The curl of F is cross F. Okay. Gradient cross F, which is equals to gradient cross gradient function. Okay. Which is 0 vector. Okay. So the line integral of F is the integration of F dr, which is integration under curve C gradient of V dr. Okay. But gradient V dot dr is del phi del x I plus del phi del y j plus del phi del z k dot with dr is dxi plus dyj plus dzk. Okay. So we can simplify as del phi over del x dx plus del phi over del y dy plus del phi over del z dz. So this is nothing but d phi. Okay. Okay, potential function phi. If F is a vector field defined by D in D, and if the F is a vector field defined in D and F equals to gradient of phi or some scalar functions phi, then phi is the potential function for F. So therefore integration of F dot dr will be integration under curve C gradient phi dot dr equals to gradient d phi equals to phi q minus phi p. Okay, let's say I just put this d phi is from p to q, so you will get definite integral. So this is the above result show that the exact form of curve C does not come into play. That is, how we go from P to Q does not matter. In other words, the line integral of a conservative field is independent of path. Therefore, an alternative way of evaluating a line integral of a conservative field is to use any convenient and simple path. For example, a line segment from P to Q. Okay, so the phi is the potential function. So the theorem about independent path. The integral of conservative field along closed loop. Integral of a conservative field along a closed loop is equal to 0. So we may write as f dot dr equals to 0. Since the simplest path from a point to the same point is no need to move. Okay. So you see some example 9 from your slide. Show that f equals to sine y plus z. I component, j component will be x cos y minus z, and then the z component will be x minus y, k component, k component is a conservative field, and find its potential function with the initial point P is a conservative field and find its potential function, okay, with the initial point P 1, 1, 0, 2, and the terminal point will be Q 2 pi 3. Evaluate the work done by integration of P to Q f dot dr using the potential function. Okay. Okay. So first you have to show that f is a conservative. You need to show that curl f equals to 0. So curl, remember curl, which means cross. C for cross. Okay. C for cross, which is delta cross f. So you have learned this before. I, J, K component Okay, then your I will be del over del x, here del over del y, del over del z. Then you are given f I j k component, so you have to write here sine y plus z. Okay, and then x cos y minus z, and then we have x minus y. So as usual, plus minus plus, I j plus k. So I repeat this to you, you will get 0, which means the f is conservative. Sure. Okay, so this shows that f is conservative and there exists a function phi such that f equals to delta phi. So this delta phi, to find its potential function, del psi del phi over del x is the f1 sine y plus z, and then f2 will be del phi over del y, that is the second component, x cos y minus z. f3 will be del phi over del z, that is equal to x minus y. Okay, so from this you can, from f1 you can find the phi by integrate them. Phi will be sine y plus z dx, okay, which is equals to x sine y plus x z plus c1 with the function of yz. Remember, you are integrating with, you integrate with respect to dx, so yz will be the constant. So same here, to find this potential function you have to integrate this x cos y minus z respect to dy. So remember, if you integrate respect to dy, xz will be the constant. So you will have x sine y, integrate cos will be sine, integrate z will be yz plus c2 function of xz. And then the final one, phi will be integration of x minus y respect to z. So this is x z minus y z plus c3 function of xy. Okay, because we are integrating respect to dz. Okay, I continue. So to find the total potential function, so please don't take the redundant, just take once. Okay, we have x sine y, and then we have xz plus xz, and then we have x sine y is already here, we don't need to take, so we take yz, and then xz is already here, we don't need to take, yz is already here, we need to take, then we have to take the c1 yz plus c2 xz plus c3 xy. So you can write as x sine y plus xz minus yz plus big C. Okay. Okay, next. Hence, using the above equation, we want to find the work done. Work done will be PQ F dot dr is equal to phi at 2 pi 3 minus phi at 102. So because the P is given 102 as in question before, and then we have Q 2 pi 3, so P move to Q, so Q have to minus P. Okay, then we have phi 2 pi 3 will be x is 2, y is pi, z is 3, so 2 from here, 2 sine phi plus 2 times 3, z is 3 minus 3 phi plus c. Okay, so this is sine pi is 0, so 6 minus 3 pi plus c. Phi at 102 will be sine 0 plus 1 times 2 minus 2 times 0 plus c. So this is result with 2 plus c. So total P to Q work done, F dot dr will be 6 minus 3 pi plus c minus 2 minus c. So which is 4 minus 3 pi. Done. Okay. So there are some example there. You can do it by yourself. So I will move to Green theorem 5.4. Green's theorem. Okay. Under a certain conditions, like simple curves with positive orientation, simple curves with positive orientation, anti-clockwise, we can evaluate a closed line integral on the xy plane through double integral by using Green theorem. A closed line integral by using Green's theorem. Okay, this integral for closed curve f1 xy dx plus f2 xy dy is equals to double integral under a certain region del f2 over del x minus del f1 over del y dA. So there are types of question for Green theorem. First, the points are provided, so you have to sketch using the given points. You have to find the equation of each curve, equations of each curves, and then you have to set your limit for double integral. Okay. Second one, the functions are provided, which means the curves provided. The functions, I may write as the functions, which means the curves are provided. So in this case, you have to sketch using the given function. If two or more functions, find the intersection. If two or more functions, you have to find the intersection. Okay, and then you have to set your limit for the double integral. So the third one, the points and the functions are provided. The points and the functions or curves are provided. Okay, as usual, you have to sketch, find the equation of the given points, set your limit. Okay. Okay. So let us see some example. Example 10. Okay, example 10. Use Green theorem to evaluate xy dx plus x squared y cubed dy, where C is the triangle, C is the triangle with the vertices 0 0 1 0 1 2 with positive orientation, which means anti-clockwise orientation, or we can call them counterclockwise. Okay, so note that we note that C xy dx plus x cubed y cubed dy is C f dot dr is C f1 dx plus f2 dy. Okay, So you have to know that this is f1, I mean before the dx, and this is f2. Okay, so as usual you have to sketch for any function or given points, any equation you have to sketch. So the curve is actually is a triangle, so you have to sketch. Okay, the points are 0 0, 1 0 and 1 2. 0 0, 1 0 and 1 2. Let's say I put 2 here, so actually it's like this. So this is y0 and this is x equals to 1, and we can find this, the gradient. So this is 1 2 0 0. We can find the equation of the straight line. You have learned this before. You will get y equals to 2x. How? You can use the formula y equals to y1 y minus y1, x minus 1, y2 minus y1, x2 minus x1. Okay, you can choose any point. Then you can choose this. You have to choose this point, and you set x1 y1, x2 y2, or here x2 y2, here is x1 y1. Okay, then what else? Positive orientation, so must be in anti-clockwise. Okay. This is 2. Okay. Next, formula of Green theorem. Okay, from question f1 is xy and f2 is x squared y cubed, so it is equals to double integral del f2 over del x minus del f1 over del y dA. Okay, then we can write as r differentiate del f2 respect to x, y is constant, 2xy cubed minus del f1 del y will be x dA. So limit, recall back your double integral in chapter 3, so refer the figure also. You can use type 1 or type 2. Okay, you can use type 1 or type 2. Okay, let's say I use type 1. Okay, then say I use a different color. From I choose a point here to here, I draw a line, so this will be okay, double integral. Type 1 will be dy dx, cut at x, so dy dx, the x part must be a constant, the last part. So the x is from 0 to 1. Your y must from here to here, okay, or here to here. So this part y0 and this part will be y equals to 2x. So 0 to 2x. So your function is the same, 2x y cubed minus x. So if you solve this, I leave it to you, you will get 2 over 3. So please check. Okay. Okay. Okay, what if, see example 11, if the function is provided. Example 11. The function is provided. Use Green theorem to evaluate y cubed dx minus x cubed dy, where C is a positive oriented circle. Positive, C is positive, is the positive oriented circle. Just now is triangle with radius 2. R equals to 2 centered at origin. So first you have to sketch. Remember, solution, sketch. So you have circle with radius 2. Okay, and it is anti-clockwise, so your theta should be 0 to 2 pi, and then your r is 2. So you have to use the polar coordinate for double integral. Why? Because it is easy. If your region is circle, you can use the polar coordinate. So from the question itself, your f1 will be y cubed, your f2 will be negative x squared. Remember, don't get mistake. Okay, so your f1 will be y cubed, f2 will be negative x squared, x cubed, sorry, x cubed. Okay, so this will be double integral from the Green theorem. Del f2 over del x minus del f1 over del y dA. So this is 0 to 2, 0 to 2 pi, r dr d theta. Remember, don't change the order. Okay, for your syllabus, just remain as r dr d theta. For cylindrical, r dz dr d theta. Okay, so in this case you have a negative 3x squared minus 3y squared. Why? Because if you differentiate f1, you will get, differentiate f2 will be negative 3x squared, and differentiate f1 will y squared, and then we have the minus sign from the formula. So you solve this. Okay, remember, your x should be r cos theta and y will be r sin theta. So substitute in the double integral, and then you will get negative 24 pi. Okay, so that's all for chapter 5 part 1b. So next I will move to chapter 5 part 2. So maybe there is A or B, A and 2B. Okay, stay tuned, see you again.